Now we have the types of loads in structural engineering. We have the dead loads, live loads, dynamics loads, wind loads, earthquake loads, thermal loads, and settlement loads. So let's talk about the dead loads. So what are the dead loads? Dead load in construction structures are designed to withstand forces that are placed on a structure, whether it is a bridge or a building, by the actual weight of the building materials required to accommodate the construction of the project. Items such as concrete, steel, partitions, floorings, ceilings, mechanical and electrical systems all place a gravity weight load on the entire structure. This load is called the dead load. So, engineers will design the structure to withstand all the forces of the dead loads that are placed on the structural members. In addition to this type of loading will be added the live load of the structure. So, in short, dead loads are the weight of the structure itself. Like for example, the beams, floors, roofs, decks, stringers, superstructures, and more. Now moving on to the next one, which is the live loads. So what are the difference between live loads and dead loads? So the difference between the two is that the dead load of a structure comprises its completed weight, usually measured in pounds per square foot, before it goes into service. The floors, walls, roofs, columns, stairs, permanent equipment, and any fixed decor constitute a static load that normally doesn't change over the life of the building. Dead loads account for non-dynamic forces that places continuous and permanent force on a structure, while the live loads refer to the dynamic forces from occupancy and intended use. They represent the transient forces that can be moved through the building or act on a particular structural element. These loads include the anticipated weight of people, furnitures, appliances, automobiles, movable equipment, and the like. In other words, loads that may move or change mass or weight, that is live load. Moving on, we have the dynamics load. A dynamic load is any force that changes with time, such as car tires, people walking, and wind gusts. Therefore, is a type of structural analysis which covers the behavior of structures subjected to dynamic loading or actions having high acceleration. So, dynamic loads include people, wind, waves, traffic, earthquake, and blasts. Any structure can be subjected to dynamic loading. Next, we have the wind loads. So the term wind load is used to refer to any pressures or forces that the wind exerts on a building or structure. There are actually three types of wind forces that would be exerted on a building. The first one, which is uplift wind load. So the uplift wind load is an upward force of the wind that would affect roof structures or similar horizontal structures in a building, such as canopies or awnings. The wind flow under the roof structure pushes the roof upwards, and the wind flow over the horizontal structure pulls the roof upwards. The next one, which is the shear wind load, is a horizontal pressure of force that can cause walls or vertical structural elements to tilt or crack, causing a building to tilt. Lastly, we have the lateral wind load. It's another horizontal wind pressure that can make a structure move off its foundation or overturn. So wind load is also the load placed by the wind speed or its air density onto a building. With high velocity winds, low pressure areas are created on the building, which creates suction pressure. Next, we have the earthquake loads or seismic loads. This is one of the basic concepts of earthquake engineering, which means application of earthquake generated agitation to a structure. It happens at contact surface of a structure either with the ground or with the adjacent structure or with the gravity waves from tsunamis. Earthquake load takes place due to an inertial force produced in the building because of the seismic excitations. Inertia force varies with the mass. The higher mass of the structure will imply that the earthquake loading will also be high. When the earthquake load exceeds the moment of resistance offered by the element, then the structure will break or damage. Next, we have the thermal loads. So, thermal loads defined as the amount of cold water, hot water, and steam used for air conditioning and in a distinct heating and cooling system. So, thermal load prediction in DHC systems is one of the key technologies for economical and safe operation of DHC systems. So, thermal loads include high temperatures during die-attach curing, heating prior to wire bonding, encapsulation, post-mold curing, rework on neighboring components, dipping in molten solder, vapor phase soldering, and reflow soldering. And lastly, we have settlement loads. When a load is applied on the ground, it increases the vertical effective stress. So this stress increases the vertical strain in the soil. This increase the vertical strain causes the ground to move downward. This downward movement of the ground is called settlement. Many civil engineers projects includes placing of loads on the ground, which produces increase in vertical effective stress. So that is all for the types of loads in structural engineering.